Hello, students, and welcome to our lesson on percents and simple interest. We have a lot to cover in this one because we're going to be talking not only about what a percent is, but also how to convert between all different forms of numbers, and also how to find percent change and simple interest. So a lot going on here. We're going to get straight on into it. So what is a percent? The word percent actually tells you exactly what it is because percent, we've learned the word per means to divide, and then cent, think about money. What is 1 cent? It's 1/100th of a dollar. Okay, so percent literally translates to out of 100 or divided by 100. So if we have something like 17%, that literally equals 17 over 100. Okay, so percent straight up just means to divide that number by 100. Now, since percentages, fractions, and decimals can all represent the same value, we need to be able to convert between them. That way we can switch our type of number we're using in the various scenarios we need. And what we're going to see in this lesson is that percents are almost always converted into decimals whenever we want to actually do something with them. So percents are useful for describing things in real life, but in mathematics, we actually really just want fractions or decimals. So you're going to see, you're going to see that we're not going to use percents all that much, except for to describe things. So in the math, fractions and decimals. All right, so how do we convert? Well, some of this we already know how to do. Converting from fractions to decimals just means to divide the numerator by the denominator. So this is what we've done in the past. If I give you a fraction and I ask you what it's equal to as a decimal, you just actually do the division, right? So if you do 1/4, 1 divided by 4 gives you 0.25. And so we can go from a fraction of 1/4 to a decimal of 0.25 just by dividing. We know how to do that part. The next part, though, we haven't seen yet. If we want to go from decimals to percents, what we're going to do is multiply by 100 or move the decimal point 2 places to the right. So for example, if we have 0.28, which is a decimal, we multiply it by 100 or move the decimal 2 spots to the right to get that that is 28%. So no real math being done there, just moving a decimal point. Nice and easy. If we want to go from fractions to percents, we're essentially going to do 2 steps in one. We're going to first convert to a decimal by dividing the numerator by the denominator. Then we'll multiply by 100. So in order to go from a fraction to a percent, we go from fraction to decimal and then to a percent. If we want to go from decimals to fraction, we have seen how to do this already. In our decimals lesson, we learned how to name decimals. So what we do is place the digits of the decimal over the power of 10 that corresponds with the rightmost place value and reduce it. So for example, we know that 0.15 is pronounced as 15/100ths. So we take the digits 1 and 5 and we write them over that power of 10 that represents the place value. So 0.15 is actually 15/100ths, 15 over 100. But then we want to reduce our fractions all the time. So we can then reduce this by dividing top and bottom by 5 to get 3 over 20. So we can turn 0.15 into a fraction by just naming it 15/100ths. And then sometimes we can reduce that fraction, in this case to 3 over 20. If we want to go from percents to fractions, we just put the number over 100 and reduce. That is exactly what I did up at the top of the screen, where I introduced 17% really just means 17 divided by 100. So this is the easiest conversion to do. When you have a percent and you want to turn it into a fraction, all you do is take the digits and put them over 100. So exactly the same way the number shows up in front of the percent sign, you put that exact thing on top of 100, and then if it can be reduced, you reduce it. And then the last one, if we want to go from percents to decimals, this is the exact opposite of going from decimals to percents. So all we're going to do is reverse that process, which means to divide by 100. And that's the same thing as moving the decimal point 2 places to the left. So if I give you 28% and I want a decimal, you just move the decimal spot 2 spots to the left and you get 0.28, which again is the exact opposite of what we did earlier. 0.28 times 100 gives you that 28%, but 28% divided by 100 turns it into the 0.28. All right, so now we're going to do a little bit of practice here. We have here a table for fractions, decimals, and percents where we have one of each filled in, and we're just going to practice converting to the other two forms. So we're going to start off with a fraction of 3 over 25. If I want to turn 3 over 25 into a decimal, I just divide. So I'm going to do a little scratch work up top. 3 on the inside of my long division setup and 25 on the outside. 25 does not go into 3, so I'd put a 0, and then I have to add a decimal place and another 0 for me to drop down. 25 goes into 30 once, so I subtract 25 down below. That leaves me with 5, and I need another 0 to drop down. So now I have 50 down there. 25 goes into 50 2 times, and so I am now done because when I subtract 50, I have a remainder of 0. So 0.12 is the same as 3 over 25. So to turn it into a decimal, all I did was actually do the division, which of course you could use a calculator for, and we will be using calculators for a lot of this lesson. Now, to turn that decimal into a percent is super easy. All we do is move the decimal place 2 spots to the right, which is the same as multiplying by 100. So 0.12 becomes 12 when we multiply by 100, and that is 12% now. All right, row number 2 here. We have a decimal of 0.761. The first thing I'm going to do is turn it into a percent because that's the easier thing. All you have to do is move the decimal spot 2 places to the right. So if I move that decimal, it'll become 76.1, and that is now a percentage. So I have 0.761 is equivalent to 76.1%. If I want to turn the decimal into a fraction, all I have to do is take it and write it over the correct power of 10. So if I were to say that decimal out loud, 0.761 is actually 761 thousandths. So I put 1,000 in my denominator there. And in most cases, we would have to reduce this fraction, but I actually gave us a number here that makes it irreducible. So 761 over 1,000 is as simple as that fraction's going to get. All right, last row, we have 104% given to us. If I want to turn it into a decimal, you go from percent to decimal by dividing by 100 or moving the decimal 2 spots to the left. So 104 becomes 1.04, and now there's no percent sign. So all we had to do was divide by 100. 104 divided by 100 is 1.04. Now, if I want to turn this into a fraction, I have 2 different ways I can think about it. I could try to write it as a mixed number first, where it's 1 and 4 hundredths. So I could write as a mixed number 1 with 4 over 100 like that. And then I could reduce that one. But I prefer that you guys don't use mixed numbers in general. Instead, I want us to just take all the digits and put it over that lastmost place value. So 1.04 is really 1 and 4 hundredths. So I'm going to write 104 over 100. I just take all the digits and I put them over that 100 that represents the hundredths place. This can now be reduced by dividing top and bottom by 4 to give me 26 over 25. I want you to notice real quick that if I skipped this decimal step, I could go directly from 104% to 104 over 100 by just taking the percentage and writing it over 100. So I could have gone directly here. I also could have done 76.1% and written it as 76.1 over 100, but then it becomes 761 over 1,000 because I would multiply top and bottom by 10 to get rid of the decimal place. So we can skip this decimal step if we want to. Just depends on what we need in our situation. Okay, a little bit of translation help now. We're going to be doing a whole bunch of percent problems moving forward. So what we're going to be doing is converting whatever the question is into an equation. That way we can solve. So step 1 is convert to an equation. Step 2 is solve. In order to convert, though, we need to know that the word of is going to translate to multiply, and the word is going to translate to equals. We've seen this in the past in the applications of solving equations lesson, but those 2 words in particular are going to show up constantly in this lesson. So I wanted to remind you of that. Now, unknown values are going to be assigned variables. Usually in this lesson, where I'm just going to be using the letter x. And the most important thing we can take away from this entire lesson, quite honestly, is that percentages are always converted to decimals or fractions before solving. So decimals or fractions, but we do not solve with it written as a percentage, because when we do the actual math, that percent symbol kind of loses its meaning for what we're doing. At least doing it the way I'm going to be teaching you here. All right, so let's dive into these. Number one says, what is 60% of 80? This is a direct translation problem. The word what is our unknown. That's what we're solving for. I'm going to call that x. The word is will always mean equals. 60% we have to convert to a decimal. So I'm going to divide it by 100 to get 0.60. Now you could use a fraction, 60 over 100, and that is perfectly fine. Because I'm going to be using a calculator to solve a lot of these though, I think it's easier to type the decimals in and to work with the decimals in general. So just know that every place in this lesson I write a decimal, a fraction is also okay. All right, so 60%, 0.60. I moved the decimal place twice to the left by dividing by 100. Then the word of tells me to multiply. But in this case, whenever we need to multiply, so this of 80 means to multiply by 80, I'm going to write the 80 in parentheses to represent that multiplication. So that right side, 0.6 parentheses 80, means to multiply the two numbers. Now this is the easiest one we have because x is already isolated on the left. All we have to do is multiply 0.6 times 80, and that is just going to give us 48. So first one, no real work to solve, just had to translate into an equation. Number two is going to require a little bit more from us. It says 162 is 18% of what number? We're always going to look for the unknown and call that our x. So what number? That number is x. Now going from left to right, we have 162. 162 is just a number, so I just copy it down directly. The word is means equals. 18% we need to turn into a decimal or a fraction. So you could do 18 over 100, but I'm going to do 0.18. And then of what number means to multiply by x. So all I'm going to do is put my x in parentheses here. And those parentheses tell me to multiply. So now I have 162 equals 0.18 times x. If I want to get x by itself, I need to divide both sides by 0.18. So I'm going to do it on the right and on the left. And after doing that, the right side will just be x all by itself. And the left side, I could work out that division by hand, but in this case, it's going to be easier to just use the calculator. And that's going to be the case for quite a few of our problems. It's just going to work out faster to do 162 divided by 0.18 on the calculator. Oops, sorry, put too many zeros there. 0.18, there we go. And this comes out to be 900. All right, so x here is just going to be equal to 900. So now to be clear what this means, if we plug that back into the original problem, 162 is 18% of 900. Okay, so 162 is 18% of 900 is what x being 900 here means. All right, number three, this is where it gets a little more complicated. We have that 135 is what percent of 160? Where it says what percent right here, the word what is what we're solving for, but that percent is on it. So what is x, but percent is still percent. I would prefer though to not write x percent in the next step because then I still have to convert it into a decimal or fraction. So just keep in mind that whenever it says what percent, we can represent that as x percent originally, okay, because it's what percent, so it's x percent. But then if we divide this by 100, we can either think of it as x over 100, which would be the fraction form, or we can think of it as 0.01x. And because I prefer decimals in this context, I'm going to be using the 0.01x. However, you get the exact same thing if you do x over 100 because those are equivalent forms of that number. So whichever one you prefer. All right, so now when I start translating this, we have 135 is just a number. The word is always means equals. What percent is where I'm going to write the 0.01x. And then of 160 means to multiply by 160, so I'm going to put 160 in parentheses. Now, if I simplify that right side, 0.01x times 160, I can multiply the 0.01 times 160, which notice is not complicated because 0.01 is just 1 over 100. So really all I'm doing is dividing 160 by 100. So I just have to move the decimal twice to the left. So 0.01 times 160 is just 1.60, and then I still have that x there. All right, and then now all I have to do to get x by itself is divide by that 1.6 on both sides. So I'm going to go ahead now and just divide both sides by 1.6. And just to be clear, 1.60 and 1.6 are mathematically equivalent. That 0 adds no value here. So we're going to end up with x is equal to, and on my calculator, I'll just work out 135 divided by 1.6 comes out to 84.375. So I could write that as my answer, or if I turn it into a fraction, it's 675 over 8. So now I want to ask you guys, because I'm going to write both here, 675 over 8 is what I'll write initially. And then I'm also going to write 84.375. Which of those would you prefer as an answer? If I asked you the question, or let's say the other way, if you asked me the question, hey, 135 is what percent of 160? And I tell you, oh, it's 675 over 8%. You would probably look at me like, Mr. K, I have no idea what that number is. You just gave me a fraction that I now, I have to work with it to figure out what that even means. As opposed to if I tell you that 135 is 84.375%, well, that's a little bit more understandable, right? We can say where 84.375 is on a number line, it's pretty close to 100%, right? Like if this was your grade we were talking about, you'd be like, oh, 84, that's a B. I can understand what that actually represents. So in this context, this decimal answer, 84.375, is a little bit more useful to us. So my basic rule for this is if the decimal does not terminate, meaning it doesn't stop. So like this one, 0.375 stops after the 5. If it doesn't do that, you should give a fraction. But if it does terminate, like this one does, then the decimal form is better because it's equally as exact, but it's a little bit easier to understand. All right, number 4. We have 2/9% of 2,700 is how much? So 2/9% is the tricky part here, but we're going to turn this into a fraction this time. Because remember that 2/9% is actually just 2/9 divided by 100. So although this one seems pretty tricky, this 2/9% over here, we can just write as 2/9 all divided by 100. Okay, then we have the word of 2,700. So whenever we see of, that's going to tell us to multiply. So it's 2/9 over 100 multiplied by 2,700, where I put the 2,700 in parentheses. Then it says is, which means equals, and how much is our x. So all we have to do is work out that multiplication on the left side. Now you could type that into a calculator, but in this case, it actually works out to be way easier than it looks like it would be. So if we go step by step here, if I first do 2,700 divided by 100, the zeros just cancel. So this becomes 2/9 multiplied by 27 equals x. Okay, where I did the 2,700 divided by the 100 first because it simplified nicely. So now I have 2 over 9 times 27. I'm going to do a similar thing where I'm going to divide first. So 27 divided by 9 gives me 3. And then I'll multiply by 2 to get 6. So by dividing 27 by 9, I get 3. And then times 2 gives me that 6 is our x value. So now let me just show you that on a calculator, it would work out the same. We have a fraction 2 over 9, and then all of that is divided by 100. So we can go ahead, and this part's a little bit hard, so let me show you. You should put the 2 over 9 in parentheses like this. Oops. Go to the side, put that parenthesis. Then we can divide this whole thing by 100. So see how now it put the 2/9 on top properly and the 100 on bottom. And then to the side of it, you have to click the right arrow to get to the side. We're then going to multiply by 2700. And notice that that just gives me 6, which is exactly what we got doing it by hand. So the reason I showed you how to do this one by hand first is it's actually kind of tricky to type that into a calculator. Whenever you have a fraction divided by something, it's good to use parentheses around the numerator to make sure it lines up correctly in the calculator. All right, moving on, number 5 here. We have that the head nurse at a hospital asked the staff, how much of a raise would make you feel properly paid? Out of 119 nurses who responded, 79 said an extra $20 an hour would be enough. What percent of respondents believe that an extra $20 an hour is enough? So we're going to convert that last line into an equation, or actually, sorry, just into a better question or a more clear question, the way numbers 1 through 4 looked. And then we'll convert it into an equation. So it says, what percent of respondents believe that an extra $20 an hour is enough? So the first part's going to stay the same. What percent? But then we're going to edit this question. It's what percent of respondents. So we know the number of respondents is 119 people who responded here. So what percent of, well, it's not going to be of respondents anymore. It's going to be what percent of 119. Okay, so we're trying to figure out what percent of 119 believe that an extra $20 an hour is enough. So we know that that is 79 of them. So we're going to say that what percent of 119 is 79. Okay, so first step is just to convert that question into a more clear question the way 1 through 4 was. Now we can go ahead and turn this into an equation. What percent, remember, is going to be our 0.01x, or x over 100, of 119 is going to tell us to multiply by 119. And then is 79 just tells us equals 79. So what percent is the 0.01x? And then we have that multiplied by 119 equals 79. So now when we actually solve for this, we can multiply right now 0.01 times 119 to get 1.19, where because it's just division by 100, I just moved the decimal place twice to the left. So we have 1.19x equals 79. We can divide both sides by that 1.19. And this one's not going to be very clean, so we're definitely going to use a calculator here. We have 79 over 1.19, and that comes out to 66.38655,462, and this likely keeps going. Okay, so let's hit the fraction button. It says that this is 7,900 over 119. Okay, well, real convenient, right? That it's 7,900 over 119 when I had typed in 79 over 1.19. So what that's telling me is that this fraction doesn't actually reduce to be anything nice. So I could technically write that as an answer, 7,900 over 119. That is the percent of people that said, yes, $20 an hour is enough. But in this case, it's a lot more understandable if we use a rounded decimal. So this question did not say to round. So technically speaking, 7,900 over 119 is the most exact answer. But we could also say that it is about, okay, where we can use a squiggly equal sign. So about would be the same as saying x squiggle, where it's an equal sign, but it's wavy there. So it's about 66.38, and I will round that 6 to be a 7 because the number after it is a 5. So it's about 66.387, and this is the percent of people. So we could also say that x is approximately, is what that squiggly equal sign means, 66.387. And that represents the percentage. So if I'm going to answer in like normal English, if someone was asking me this question, then I would want to give them this middle answer here. If someone asked me, out of 119 respondents, 79 said it's enough, what percent is that? I would say, well, it's about 66, and I'd probably even round this further. I'd say it's just about 66%. But depending on what the question is written as, determines how many decimal places you would need to be correct. So if it doesn't allow you to round, you have to give the fraction. But if I'm speaking to someone in real life, I'm going to say that this is about 66%. So it's all based on context here. All right, number 6. A patient's bill was $1,200 before insurance. If the insurance covers 80%, how much does the patient pay? So now, to be clear, the insurance is covering 80%, and this is asking how much the patient pays. So 100% minus 80% means that the patient is paying 20%. So then our new question becomes, what is 20% of the bill, which is 1,200? Okay, so we just have to figure out what is 20% of 1,200. This is going to translate to x equals 0.2 multiplied by 1,200. So all we have to do here is multiply 0.2 times 1,200. That is going to come out to 240. And then we're talking about money in this case. So we would say that the patient pays $240. And just to be clear on number 5, I could answer in words that the percent increase, or sorry, the percent of respondents that agree that $20 is enough is about 66%. So I'm going to clarify that up at the top here. We would say about 66% agree that $20 is enough. Okay, for our current one though, number 6, 240 tells us that the patient pays $240. All right, number 7, a hospital increases its nurse staff by 15%. If there were originally 120 nurses, how many are there after the increase? Because we are increasing by 15%, that does not actually tell us to multiply by 0.15. Okay, we start off with 100% of our staff, and we're increasing by 15, meaning adding 15%. So that is 115% of what we used to have. So what we are actually trying to answer is, what is 115% of the original 120 nurses we had? Okay, so an increase by 15 means that we are increasing to 115% because you start at 100. So now we can translate this directly. What is, it's going to be x equals 115% is 1.15, and we're multiplying by 120. So all we have to then do is multiply this out. 1.15 multiplied by 120 gives me 138. So we would say that x equals 138, and then we can write in words what this actually represents. There are now 138 nurses. So the question specifically said, how many are there after the increase? So that's why it's the total new number of nurses, 138. If the question had just asked how many new nurses there are, then we wouldn't have multiplied by 115%. We would have just found 15% of 120, and that would represent the increase, which would end up being 18 because the difference here is 18. But because it wanted the total number of nurses at the end, we do 115% of 120 to find the new total. All right, now we're going to talk about percent change next, which we were kind of using in those last couple problems, but without really knowing what in particular it actually means. So percent change compares the difference between two values and it makes it relative to the original value. So instead of just telling us what the change is, it puts it in perspective based on how much we started with. So the formula is pretty simple. Percent change is the new value minus the original value divided by the original value. So we have original value in two spots in this formula. And then we multiply by 100 to turn it into a percentage. So the fraction here gives us a decimal, and then we turn that decimal into a percent by multiplying by 100. If this result ends up being positive, it's going to represent a percent increase. And if the result ends up being negative, it's going to represent a percent decrease. So we don't have to think is it an increase or decrease. Whether it's positive or negative will give us that information. So number 8 here says a hospital's supply costs increase from $2,000 to $2,600. Find the percent change. So we're just going to plug in directly. PC for percent change is going to be equal to the new amount, which is 2,600, minus the old amount, which is 2,000, divided by the old amount, which is 2,000 again, multiplied by 100. So all I'm going to then do is type this into my calculator as is and see what we get. We could try to work it out by hand, and it ends up not being too bad. The top is 600, and then 600 divided by 2,000 is going to give us 0.3, and then when we multiply by 100, it's 30. But for a lot of these, you're not going to know if it's a clean number or not from the beginning. And so if we put it into our calculator first, 2,600 minus 2,000, all divided by 2,000. Notice that gives me 0.3. But then if I multiply by 100, I get the actual percent change, which is 30%. And this is a percent increase because it's positive. So again, we could have done that one by hand. And actually, for myself, I probably would have. But you're not going to know going into it how clean it's going to be. So I recommend for most of these, it ends up being a little bit quicker to just do them with the calculator. All right, number 9, a patient's cholesterol level decreases from 240 to 210. Find the percent change. So we're going to have that PC is equal to the new amount is 210 minus the old amount is 240 divided by the old amount, which is 240 again, and then multiplied by 100. When we go ahead and calculate this, we're just going to do a new formula where on top we have 210 minus 240. Notice that that's going to be a negative number. And so our percent change is representing a decrease of, in this case, we get negative 12.5. So this person's cholesterol decreased by 12.5%. So negative 12.5%. And if you wanted to not use the negative sign, you would just have to use the wording, that it is a decrease. So we can either say that it's a 12.5% decrease, or we could say that the percent change is negative 12.5%. Both of those represent the same thing. All right, last thing here, simple interest. Interest in general is the money paid for borrowing or earned for investing money. So when you borrow money, you pay interest, and when you invest money, generally you accrue interest or earn interest. Simple interest is the most basic type of way of calculating interest we have, where interest only accrues once per period. Now, this is eventually, not in this class, but in future courses for you, going to be turned into compound interest, and then we'll talk about annuities and all sorts of other financial terms. So this is the building block of all those other types of interest. But before we can understand those, we first have to get down simple interest, where interest just accrues once. If one of the variables is missing, which is going to be the case usually, then we solve for it using the formula. So when you do this on your homework or somewhere where you're doing a lot of these, it would make sense to solve the literal equation. So to solve this actual formula over here for the variable you want, so you can plug things in multiple times. But because we're only going to do one of each in this lesson, we're just going to plug in the values and then solve for the variable. So it's up to you if you want to solve for the variable first and then plug in the values, or if you want to plug in the values and then solve for the variable. All right, and then just as a note, it's not going to be relevant for us here, but in future classes, we will kind of make these problems a little bit harder by giving you different units. And so just be aware that the rate and time must use the same units. So if it's an annual rate, it needs to be a time in years because annual means yearly. And so our time would need to be measured in years. But if it was a daily rate, then we would need a time in days. Or a monthly rate, we would need a time in months. So just always look out for that because they need to be the same. All right, so now the formula is I equals PRT, where we multiply P times R times T. I is going to represent the interest that we are either earning or paying. P is called the principal, and that is the starting amount. So it's either the amount you borrow or the amount you invest is called the principal. R stands for the rate, which is the interest rate. And this is going to be given to us as a percent, but we need to use it in the formula as a decimal. And then T represents time. All right, so the most important thing there is that we turn rates into decimals. So number 10 is going to be the most basic one, where all we have to do is plug in. So it says find the interest, meaning we're solving for I. A loan of $2,000 is taken out at a 6% annual rate for 3 years. So we're going to set this up as I equals the starting amount of the loan, the principal is 2,000. The interest rate is 6%, but I can't plug in 6% directly. I need to plug it in as 0.06. So I turn it into a decimal. And then the time is 3 years. So we're going to multiply by 3. Now notice the way I just wrote it. I used dots for multiplication because that's what the formula used. I recommend you don't do that. Okay. Instead, it's a lot easier to read this if you use parentheses to represent your multiplication. So if I put the 0.06 in parentheses and the 3 in parentheses, now it's a lot more clear what this is representing because my decimal point and my multiplication dots don't get confused. All right, but to actually solve, we're just going to type this into a calculator and see what we end up with. So we have 2,000 multiplied by 0.06 multiplied by 3, and this comes out to 360. And that 360 means that the interest accrued is $360. So I just throw a dollar sign on it to represent my units. Number 11, we're going to find the principal. So we're solving for a different variable here. The interest earned is $450 at a 5% annual rate over 3 years. So 450 is what I'm going to plug in for interest here. So it's going to go on the left side now because that's my I. 5% is my rate. So that's going to be 0.05. My number of years is 3. And the thing we're solving for is the principal. So I'm going to make the principal just the letter P, the way it appears in the formula, because we're now going to solve for it. So now if I simplify the right side a little bit, I have 450 equals P multiplied by 0.15 because 0.05 times 3 is just 0.15. And then now all I have to do to solve is divide both sides by that 0.15. So when I type now into my calculator, 450 divided by 0.15, it comes out to 3,000. So that tells me that the principal was $3,000. So I throw my dollar sign on it. And what that means in context is that in order to earn $450 of interest at 5% over 3 years, I would need to invest $3,000 to make that happen. All right, number 12 is the hardest version of this, which is where we find the rate. Okay, and the only reason it's the hardest is because we have to remember to convert to a percent at the end. Because notice in the first two problems, the rate was a percent. So when we set this up, it says the interest is $1,200. So that's going to be my I on the left side. And we invested $4,000 into this loan for 2 years. So my principal is 4,000. I don't know what my R is, so I'm just going to put an R in there. But my time was 2. So I have 1,200 equals 4,000 times R times 2. If I simplify that right side, 4,000 times 2 is 8,000. So now all I have to do to get R by itself is divide both sides by this 8,000 number. So if I go ahead and work out 1,200 divided by 8,000, That comes out to 0.15. So what I have here is that 0.15 is equal to R. And that's great, except for that is not how we write our answer because we need to give R as a percent. So 0.15 is the decimal. If we multiply it by 100, we get that R is equal to 15%. And so we would say then that the interest rate for this loan was 15%. All right, that's all I have for you guys in this one. Hopefully you learned a little bit about simple interest, and I will see you in the next one.